work B. This is on the back of bell work A. This is on the back of bell work A, so you'll have to turn a couple pages past your flashbulbs and mole ratios lab from yesterday. This is on the back of bell work A that you did yesterday. I want you to get cooking on this. This is you. Your quiz on Friday will look a lot like these bell works, okay? If you want to pull out your phone, go into the Wednesday folder and look at the answer key for this while you're working on it. You can do a couple, check a couple. You're more than welcome to do that. Let me give you guys a few minutes to do this as I come around the room, check the temperature. So go ahead, conversions, bell work B, get her going. Now, I highly doubt any of you guys finished this entire thing. Maybe you're kind of close. Some of you guys are feeling strong at this. I'm going to go through this kind of quickly, one from each section. Okay. Now, the reason why I'm going to do this quickly is there are several reasons for that, actually. Because the answer key's in the Wednesday folder, so if I got a little too fast, you can always check there. I am going to post this recording in the Wednesday folder as well, so you can always kind of play that back if you need to. And at this point, we've been doing these for a couple of days. If you are still taking a little time to do these, that's okay, but you need to do a little bit more heavy lifting at home. You need to do like this whole bell work at home, which is not super long. Again, it's just one-sided. It's like 8 total problems or whatever. Some folks may not need to do any of the bell works at home, but some of you guys probably do, okay? I'm not going to make you do problems you don't need, but they're there for those of you guys who do need to do a little bit more lifting at home, okay? So this first section, I'm asking you to go from grams of a compound to moles of a compound, or vice versa. Now, if we remember that moles equals mass over formula weight, we're looking at this first one. Your moles will be equal to that mass divided by whatever the formula weight for barium bromide is. Okay? So whatever that is, there you go. This one over here, you already have the moles, and so that should be equal to the mass divided by the formula weight, as always. Now, you're solving for mass in this one, so you're going to have to get it by itself. So you need to multiply both sides by the formula weight, like this. Okay? Oh, that doesn't cancel out. Mr. P. Stus, algebra. Formula weight over here will cancel out, though. So in other words, formula weight times the 2.34, that will tell you your mass, if you're starting with moles. Okay? Now, in red, I'll do the next section. This next section is actually mathematically the easiest by kind of a lot. But some people are like, Mr. P, don't say that. I was just stuck on this. The hard part, this section is hard because it's hard for you to understand what I'm asking you to do. Once you get it, though, you're like, oh, that's it? That's not that bad. That's not that bad. It's sort of like the arrow in the FedEx trucks. Once you see it, you can't, like, unsee it. You're like, oh, I get it. Okay. If you don't know what I'm talking about, you should Google the arrow in FedEx. It's going to blow your mind. Anyways, so this one right here, I got 0.6 moles of lithium sulfide, that whole thing. And I'm asking you for the moles of each element. Okay, cheese sandwiches. If I got 10 cheese sandwiches, you guys would automatically know that there are 20 slices of bread, right? Because it's like a ratio thing. And so in the same way, if each lithium sulfide has 2 lithiums in it, then there will be a total of 1.2 moles of lithium in that whole thing. If each lithium sulfide has 1 sulfur in it, so 1 times the 0.6 that you have, that means there'll be 0.6 moles of sulfur in that whole thing. And notice how I'm putting a box around this guy. And notice how specific I'm being with my labels. I'm not just writing 1.2, I'm writing 1.2 moles. I'm not just writing 1.2 moles, I'm writing 1.2 moles of lithium to distinguish from 0.6 moles of lithium sulfide. Does that make sense? Putting a box around everything. Now, this final section down here, what's really happening is you're going to start by doing part A, up here in green. Then you're going to have a second step that's just like this stuff here in part B in red. And then it'll have a third different step that I'll do in blue. So, here, how many grams of each element? I want each element. Each element. So the first problem, that would be grams of iron and the grams of chlorine. Now to get there, I need to first find out how many moles of the whole compound I have. Well, okay. Well, remember moles. My moles equal my mass over my formula weight. For iron chloride, I believe that's 161. So iron is 56. Each chlorine is 35. So 56 plus 35 plus 35 plus 35, that adds up to 161. This will come out to be 0.03. Has anyone done this one yet? I think it's 0.3. Can we do that one? Yeah, okay. 3 moles, and I'm being very specific with my label, FeCl3. Okay, now to the part B section of this. In red. I'll do it in red so I'm consistent. Now I want to know how many moles of each element we're talking about. So if I have 0.03 moles of iron chloride, if there is 1 iron in each one, so 1 times that is 0.03, that means I have 0.03 moles of just iron. That also means I have 3 chlorines in each one of those, so 3 times 0.03 means I have 0.09 moles of just chlorine. I've had this great question several times today, Mr. P, but like 0.09 plus 0.03, that adds up to more than the original you had. Well, you could say the same thing about cheese sandwiches, right? Like, well, 20 slices of bread plus 10 slices of cheese, that's like 30 pieces, but you only have 10 sandwiches? Like, well, those things don't have to add up because those are all different units. Slices of bread is 1 unit. Slices of cheese is another unit. Sandwiches is a third different unit. Those are apples and oranges. And it's just a ratio thing. You can have more slices of bread than sandwiches because it's just a ratio. There's 2 slices of bread in every sandwich. Okay? So, now I know how many moles of each one. And here's the third different step. I want the mass of each element. Remember, circled in green, mass of each element. Okay, well, I know the moles of iron by itself. Moles equal what again? Mass over formula weight. So the mass, which is what I don't know, over the formula weight of just a single iron now. We used iron chloride before because our units were FeCl3. When our units are just Fe, we're using the formula weight of just Fe. Same thing for chlorine. Now that we're only talking about 1 chlorine, talking about formula weight 35. And you'll solve for mass on both of these. In the Wednesday folder, on the answer key for this worksheet, I go in even more detail, on my answer key, where just everything is labeled to a fault. You know exactly where everything came from. I write out every step. Okay? So if you want a super detailed version of this worksheet here, answer format anyways, go ahead and check out that Wednesday folder. Do a couple problems, check a couple. You need to do what you need to do tonight to make sure you are ready to roll for tomorrow and especially Friday when we take this quiz. Okay? Go ahead and turn to your lab from yesterday. Flashbulbs and mole ratios, a couple pages earlier. Yes, sir. Friday's the quiz. Okay. Friday's the quiz. So getting ready for tomorrow, because you'll need these skills on tomorrow's lab, but Friday's when the quiz is. Does that make sense? A couple labs in a week. A couple labs in a week. So we're here. Okay. Now, if you were absent yesterday, you can either use your partner's data, or you can use this data up here. Either one works. So, the key thing is that you are using the same principles that I am as I go through these post-live questions. These are my numbers. Your numbers are not the same as my numbers. They're hopefully kind of similar at times, but your numbers will be different than mine. So as long as you are following the same principles, you are in good shape. Okay? This first question, what type of chemical reaction is this? Well, here's my arrow right there. There's only one thing after the arrow, so what do we call this type of reaction? Synthesis, right? Because syn, S-Y-N, means like one or like together. Hey, we got synergy. That means we have the same together energy, whatever. So synthesis is when you smush everything together and make one thing. How would I explain that? Well, I write synthesis, and then in keywords over here in red, one product. If this was a quiz and you wrote synthesis, and you just put like a little arrow, like there's only one product, that's all I need. I don't need a full sentence. As long as you make it clear you know why it's synthesis, we're good. Now, question number 2. Calculate the number of moles of magnesium. Just magnesium, which is what you started with. Well, equation for moles is mass over formula weight. So I'm going to use the mass of my magnesium ribbon over the formula weight of magnesium. What's the formula weight of just magnesium by itself? 24, because it's element number 12. Okay? So whatever your mass was, divide by 24. In my case, that was 0.14. So my 0.14 divided by 24. Again, you should use your own numbers. So I got 0.0058 moles of magnesium. And of course, I'm a model student, so I'm going to go ahead and put a box around that once I got labeled. I don't know what your number will be, but it'll probably be something similar, like maybe it's a 0.0041 moles of magnesium or 0.0079 moles of magnesium. This is the neighborhood you want to be in, but it does not have to be 0.0058. In fact, it almost certainly won't be unless you start with exactly 0.14 grams of magnesium, which maybe one of you guys did, probably 0 of you guys did. Okay, all good so far. Now, the next question is, how would you determine the mass of the product of magnesium oxide that was formed? So we burned this magnesium, we made some magnesium oxide. How could we find out how much magnesium oxide we actually made? How could we do that? Any ideas? Yeah, Spade?
Could we somehow get the, or find out the, how many moles are in the MgO, and then do some sort of fancy stuff, then get it?
That would work, but you would need the mass in the first place to find the moles of the MgO, potentially. Josue? My God, that's what I'm talking about. Okay, if I just reveal the words here, not even like paying attention to the numbers, but if I just go like this, if I have the mass of the crucible and the magnesium oxide, which is what you got at the very end, if you just subtract the mass of that empty crucible that was the first thing you got in lab, then the only thing left would be the MgO. Which is awesome in this lab because that MgO gets stuck to the sides. It's like hard to even scrape it all out. Like you're always going to lose some. And it's like, oh, well, sweet, screw you, magnesium oxide. I already know that the crucible was empty, so I don't even have to actually measure you directly. I can just know what you are. So in my case, that was 12.84. That was at the end. I subtract my empty crucible, which is 12.61. So I had 0.23 grams of magnesium oxide. And there goes the box. Do you notice how just putting grams here wouldn't be good enough? Because we already had grams of something else earlier. We need to make sure we put grams of MgO. Be specific. Yes, sir?
Well, I just want you to scroll to the top so I can see what your 12.84 was. Okay, so
that was the mass of my crucible and my magnesium oxide. Does that make sense?
Mm-hmm.
Yep. Okay, the next question. All right, well, that's how many grams of magnesium oxide you got. How many moles did you have? Okay, well, moles equals mass over formula weight. Before, my formula weight was 24 because I was just talking about magnesium. But now I'm talking about magnesium oxide. That's an Mg and an O. So got to add 16 to that 24. So it's your mass divided by 40 this time to find the moles of your magnesium oxide. Okay. Now in my case, that's 0.23. So 0.23 divided by 40. That's coming in hot at a 0.0058 moles of MgO. Look how clear I am with my labels. Look at that beautiful box. Boom. Mr. Pilcher, why do you keep emphasizing the box thing? Like, don't we always do all our quizzes and stuff on Schoology? Where that's not really, we don't need to do that. Schoology is going to be your quiz this week, but that will probably be your last electronic quiz of the year. We're probably going back to paper after that.
That's not really cool.
So, you're going to want to be putting boxes around things, and you better be labeling everything on all your stuff.
Mr. Pilcher,
Uh-huh.
can I just express how uncool of you that is?
Sounds good. All right. Good talk. Yes, Meg.
Does it still count if you put a circle around it instead of a box?
I'll think about. Yeah, that's fine. That's fine. Yeah.
he's not calling on you again.
All right. No questions. Okay. Good talk. Now, number 5. As the magnesium ribbon was burning. Okay, so we burned this magnesium ribbon. Was the mass increasing or decreasing? What happened to your guys' mass? Did it go up or down? It went up. Okay. I think everyone's went up, right? Now, think about that. Some people are like, wait a second. Law of conservation of mass, you can't just have mass show up out of nowhere. Oh, that's right. That's exactly right. We left the lid open a little bit so oxygen from the room could go into the crucible and grab that magnesium. Okay? That's where the extra mass came from. So you can explain this a lot of different ways. I just feel like the mass increased, oxygen from the air entered the crucible, something like that. Some people on quizzes, if this was their thing, they would draw a picture of a crucible and then have an arrow with like oxygen going into it and be like, boom. That would be a perfectly fine explanation to me. Okay? As long as you label like, hey, this is oxygen going in, whatever. The nice thing about paper is that you can show me what you know a lot of different ways.
Be creative.
Yeah, you can be creative. And it also allows people to kind of like, okay, I think of it this way, I think of it that way. And as long as you get to the correct answer several different ways, I'm cool with that. All right. Yeah.
Are we allowed to put our answers in pentagons?
Instead of circles or squares or boxes, I'm cool with that, yeah. I had a kid ask me if they can put their answers in trapezoids one time. I was like, sure. Anyways, what mass of oxygen was used in this reaction? So how much oxygen was used in this reaction? Can anyone tell me how to find that? Yeah?
Take the mass of the ribbon, or you take the mass, the final mass of just the MgO and subtract the ribbon mass.
That's right. So again, we just look at the words here. Okay? If I just had MgO and I subtract the Mg from the beginning, that should give me the mass of the O by itself. My numbers, I had 0.23 MgO at the end. I started with 0.14 Mg. So that means that 0.09 grams of oxygen must have grabbed that magnesium during the lab. There's nowhere else that could have come from. So, boom, 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 box. Here we go. Labeled everything. Grams of magnesium oxide, grams of magnesium, grams of oxygen. Labeled everything because there's 3 different kinds of grams in there. All right. Lastly, compare your answers to questions 2 and 4. What is the mole ratio between these two? Okay? Now, I don't want an ugly like, oh, it's 0.0035 to 0.041. 0041. Like, no. Clean it up for me. Get it to a 1 to something ratio like we did the dehydration lab. Clean up that ratio for me, okay? Round to the closest whole number. I'll give you guys a few seconds to do that. But in my particular case, I had 0.0058 moles of magnesium and 0.0058 moles of magnesium oxide. To clean those up, I'll divide by the smaller of those two numbers, which in my case are the same number. So just divide by 0.0058. And I got this ratio right here, 1 to 1. How many folks got 1 to 1 with their data? Did I get any 1 to 2s out there? Are there any 1 to 2s out there? Really? No one got 1 to 2? Did anyone get 1 to 3? Huh, okay. This answer should be 1 to 1. If you got 1 to 2, that's all right. Go with what your data says. Okay? You'll notice I'm saying it should be 1 to 1. It should be 1 to 1. How could I possibly know what the ratio should be? Okay? How could I know that? So if we flip to the next page of your lab, it'll look like this, the post lab. Here's how I know. This is your balance equation you guys wrote at the beginning of the lab. Okay? 2 mg's plus O2 makes 2 mg's. You balanced it, right, with the 2's there? Here is how I know. So if I have 2 magnesiums and 2 MgOs, that's a 2 to 2 ratio between those two. Or simply put, that's a 1 to 1 ratio. For every mole of magnesium, I should have exactly 1 mole of magnesium oxide. And here's the big idea. Coefficients, I would put big fat stars all around this. Coefficients tell you the, all caps, mole ratio. This is the big idea. This is the whole reason we did yesterday's lab. Is to prove that the coefficients tell you the mole ratio of everything in a chemical reaction. So I wanted to discover it in lab. Prove it to you first.
But that's not as easy.
Yeah.
It's not as easy, but easy's lame. Sometimes. Don't you ever have a class where it's like super easy and you like it's not your favorite class because you're bored all the time?
Yes. This one.
Right here. I'm at it. All right. So let's put this into practice. Go ahead and balance this one for me. Na plus O2 makes Na2O. Balance that. Balance that one for me.
Wait, this one?
Yep, it's right below, yep. Na plus O2 plus makes Na2O.
Wait. Wait. What are you doing?
Wait,
The mole ratio.
what? Yeah, okay. Never mind.
Okay. So, when I balance this, here's what happened to me. I was like, all right, I'm going to slap a 2 there. Yep. Okay. Oh, but I need a 2 here to fix my oxygen. Oh, wait, my sodium's goofed up. Okay, so I guess I need a... I'm guessing a lot of you guys just did the same thing. I got a 4 to 1 to 2. So, here's how this works. I'm going to really exaggerate my work that I'm going to show you here to make sure there's no confusion. Okay. So, if I had 40 billion O2s, if I had 40 billion of those, how many sodiums would I need to go with that? Well, let's draw the invisible one that's here. So there's a 1. Here's what I'm going to do. That would be a 1 to 4 ratio. And that's why I put an arrow so I know which direction I went. So what do I have to do to a 1 to make it a 4 mathematically? Multiply it by 4. Got to multiply by 4, right? So if I need 40 billion O2s, how many sodiums would that be? That'd be 40 times 4, 160 billion sodiums. If I'm going the other direction, okay, well, so how many cheese sandwiches is that going to make? How many sodium oxides is that going to make? Well, that's a 1 to 2. Again, I'm drawing the arrow so I know which direction I'm going. So that's a times 2 situation. Because you have to multiply 1 by 2 to get it to become 2. So how many sodium oxides will this make? 80 billion.
Oh, Billy, does it say? What's that?
Billies. Whatever. Okay. All right. What about this next one? I have point. So now this person's like, okay, all right. So before I asked you about cheese, what if I started talking to you about bread? Like, okay. Well, if I had 0.8 moles of sodium, how many moles of O2 need to go with that? Okay, well, that's a 4 to a 1. Notice the arrow. Before I went 1 to 4, now I'm going 4 to 1. So what do I have to do to a 4 to make it a 1? Divide by 4, yep. So 0.8 divided by 4 would be 0.2 moles of O2. And answer already got revealed there. But if I want to go to the Na2O, okay, what do I have to do to 4 to make it a 2? That's a divide by 2. So 0.8 divided by 2 is 0.4 moles of Na2O. And because these are ratios, you can use any of them to go to any of the others. So I just went from sodium to Na2 and I got an answer of 0.4. But the same should hold true if I were to go from the oxygen to the sodium oxide. Okay, this is a 1 to 2 ratio. All right, so I got to multiply it by 2. Well, if I have 0.2 moles of oxygen, 0.2 times 2 is 0.4. So it should hold true either way. Just like, hey, if I got 10 slices of cheese, you could go back like, all right, so that means you need 20 slices of bread, and that also means you would make 10 sandwiches. But if I start with the bread, 20 slices of bread, like, okay, well, that means you need 10 slices of cheese, and you can make 10 sandwiches with that. Or you can start with the sandwiches. It's a ratio, so the relationship will always be the same. Yeah?
Can I ask, how often do you eat a bread and cheese?
Never, ever. That sounds terrible. But it's a really simple image that can anchor this knowledge into something you already know.
Maybe just make it like 1 slice of turkey or something. Something a little more.
Yeah, like a ham sandwich.
Yeah.
It's because later on I buy cheese sandwiches as like a visual, and the cheese lasts a lot longer in the fridge than the turkey. Truth be told. Also, a slice of turkey can kind of fall apart, and they're all different shapes and sizes, where the cheese is just like, it's exactly this square.
Okay.
Make sense?
Okay. Some people are fancy and go get those.
So, we got 5 minutes. Let me remind you guys of a few things. Tomorrow we'll be doing the same lab as yesterday, but we'll be coming from a different direction. So it'll be the same process, but different thinking. Okay? I'll leave it at that. On Friday, you will have a quiz that will look a lot like the bell work A from yesterday and the bell work B that you just did earlier this period. The last thing I'd like to point out to you, I think maybe one or two of you tops did these yesterday. I don't blame you because we went bell to bell with lab, but there were lecture questions from yesterday. You got 4 minutes. I suggest some of you guys do those now if you got time. No. The 3 things you are responsible for turning in on Schoology this week are the Monday lecture questions, the Tuesday lecture questions, and this Friday's quiz, which you'll be doing in person with me anyways. So if you've done the Monday already, the only thing you need to remember are the Tuesday questions.